Okay, welcome to 52 weeks of exploring interesting languages. I'm back after a brief hiatus. I have been currently studying Julia. I'm going to keep going through Julia for a bit, and then if I get bored, I'll hop to some other weird language. But for now, Julia seems to be pretty cool. So I'm going to keep going down the Julia route. I'm going to go ahead and share my screen and, and keep going here. So basically, with Julia, what do we care about? I'm going to go to Julia. Hopefully, have here we go, Julia, getting started. And I don't remember what episode I'm on. I can probably find out pretty easily by looking at the last number. And I believe last episode was 2, so we're on 3. So I'm gonna go ahead and put episode 3 here. We'll just cover. We'll go top first here because it's going to be easier instead of having to go to the bottom of the page every time I do new things. So episode 2. So I think we covered functions last time. So I need to go to the documentation at julia.org. And I don't know yet what I'm going to cover. So what did we do last time? So we got documentation, manual. So I was on functions last time. And argument passing, all that stuff. I don't know how far I went, but I think, wow, this is a big section actually, right? Because functions it's a huge section actually. So there's no way I went through all of this. So let's go a little bit more down the functions here, and I'm going to put that in documentation and just say more functions because I don't remember, and doing things multiple times is not a bad idea. So I'm going to open up another tab here, and what I'm going to do is again use my GitHub code spaces environments, and I'm going to see where it says friendly Fiesta. I'm going to launch this, and the nice thing is that it's going to remember everything I did last time, which is awesome. I love it when it remembers everything I did before the time before. Okay, let this thing wake up. I don't know if it speeds it up to refresh it. Maybe it doesn't. But it is kind of taking a little bit of time. Okay, come on, wake up. Yeah, I do kind of want to use this environment. Okay, good, because who knows what I did to it already. We'll go to new terminal. Okay, reload. Sure, we'll reload. Okay, so we got GitHub code spaces. We've got all kinds of fun stuff in here. We can do it. I guess actually, git pull. We can edit this. Let me just commit those changes, and then I'll do a git pull. There we go. So we add some changes here. And what I'm going to cover is there's a lot more stuff on functions. So I'll put a link to the documentation. We'll go here. We'll say material for today on Julia functions. And let's put this inside. Here we go. Okay, so what do we care about with Julia functions here? Well, first let's look at the file system real quick and just take a look at what I got going on. So I have Julia installed. That's good. And I don't really have like a structure yet. Right, I have some files, which is kind of cool. But I think one thing that could be an issue here is how they want you to actually build like a structure in your code. And maybe I need to look at that first. So we see, there we go, standard library, projects. Do they have any documentation on projects, structure, base? Okay. Huh. Getting started. So maybe they want, do they even have like a cargo kind of thing? That's not a good sign actually. But, let me look at this. Let's see, package managements, Julia. What do they got? Okay, so they have a tool called PKG. It's a built-in package manager. I see. So you enter the REPL, you do package. Okay, activate tutorial. Interesting. So, yeah, I don't understand yet. It looks interesting. That there's a package manager, and I'll put this into the documentation right here and just maybe put like references or something. We'll say references. But yeah, I think I didn't cover this because I don't even remember it. I had to take a break for a second because of an injury, but let's go ahead and say, let's assume we did nothing with functions. So Julia package managements. I'm not going to start from 0 here then with functions. But I would say probably the first thing I need to do is make a directory called, I don't know, like Julia functions or something like that. And I'm going to CD into it. Now first, let me double check that Julia works. Okay, the REPL works. That's good. Perfect. And next up here, let's go to functions. So let's start at the very, very beginning. So in Julia, a function is an object that maps a tuple of arguments to a return value. Julia functions are not pure mathematical functions because they can alter and affect the global state. So they can mutate the global state. And in this case, if we said Julia function, this would be like a hello world kind of function. So it's true that you could just do this from the REPL. Let's try it both ways, right? So first, what I'm going to do is I'm going to touch, and we'll call this like hello func or something. And we want to end it with JL. And let's first just see if we can get that to work. And there we go. So we have a really basic function that is called F, which I don't like. I mean, that's kind of a weird name. I guess sure, but not great. And if I go ahead and I just say Julia hello, does that compile? Does that do that? Well, it doesn't. It didn't actually. Well, it ran it, but we don't have anything going on in there. And if I do Julia, which is probably a good idea, we can try this out from the interpreter. And that looks good. And let's go ahead and do this. Let's say function. And I guess I could just grab this line. Go here. Function. function, and then we'll do x plus y, and then we'll say int. So that's reasonable enough. And then if I pass in 2 and 2, does that equal 4? Okay, cool. All right, so let's try that. Let's just say f 2 and 2. And I forget how you print in Julia, but let's call this z, and then we'll do, I don't know, print z. I'm gonna, you know what I think I'll do is I'll have 2 terminals so I can toggle back and forth, right? So this is an interpreter, this is regular bash, and if I do Julia, hello world, oh, I need to cd into Julia functions. There we go. And we can do Julia hello func. There we go. Cool. Okay, well that works. I think I remember covering the strings, and let's just double check how I make something, like what's the canonical substitution method here. It probably got some kind of bracket. Okay, where's like, here we go. Triple quoted, string basics. I don't know how you do string substitute, like a template. Common operations, here we go, common operations would be this. Yeah, I don't see a real clean like template example here without digging into it a little bit more. Well, I guess for now, I'll just, it's kind of a bummer. Unless it wants me to do concatenation. Yeah, like there's no print. Like I just want to print, I want to print like a variable. How do you, oh, print ln. Oh, I like that. Okay, here's print. So this is closer to what I want. And print ln, not a comment. It's looking good. Yeah, okay, let's try print line, and then I can always make things fancier later. But basically, I could just do like, I don't know how to substitute this. I mean, I guess I can guess and say, this is my value or something like that. I really don't know. Kind of a bummer. They don't have a really good example of that in strings. Common, non-literal. I mean, I could Google it and say, Julia string substitution or print variable string. There we go. You do this. A variable and comments. Oh no, I don't want to do that. Huh, so it's kind of old school style. Let's try that. Let's go here. Now let's do this. This is my value z, like that. Does that work? Julia, hello. Oh, okay. So you just put a $sign to print it out. So we are able to get a function working. We got this working, and I know now how to print out strings that look pleasant. Right. So I've got that working. Perfect. So next up, we can go back to functions. I mean, really, that's an essential thing to know when you're playing around with things. So obviously, we can call it. Without parentheses, the expression returns to the function object. It can be passed around, right? So if you just It makes sense, right? If you swap one variable, it'll just take that new form. Unicode can be used for function names. Yeah, probably I don't care about that, but argument type declaration. So you can declare the types. Now, is it required? Is an interesting question. The type declarations can be useful if the function only returns for a certain type. Oh, I see. So you can add an explicit. So the value returned by function is the value of the last expression. So just like Rust, which I was just playing around with, but you can do an early return here and do an explicit return. So that's good to know. So in this case, where I typically would do something like this is I would say like if something happens, return early and break out, which is exactly what they're doing. These are basically conditional statements that return different values based on different conditions. And you also can return the type, which is pretty neat. So this converts the return value to a specific type. That's pretty useful. And you can also return nothing. Oh, you call it actually nothing. Operators are just functions. Oh, I see. So these are just built-in functions inside of Swift. So if you say plus, it's just adding that. Operators for special names. Wow, there are a few special calls to function with non-obvious names, hcat, vcat, etc. Then there's anonymous functions. So functions in Julia are first-class objects, and they can be assigned to variables and called using the standard function call syntax. They also can be created anonymously without giving a name. And so here we go, x to the second power plus, so we have an equation, and we just say function. Oh, I guess that's weird. Yeah, so function, there's no name. That's weird. Generic. This function takes one argument, returns it. Notice the result is a generic function with a compiler-generated name. So it just kind of gives you a name, which is weird. The primary use is to pass the functions which takes functions as arguments, which is very common in functional programming. Or in pandas, right? You do the same thing. You pass a function that gets run on a vectorized data frame. There we go. Map. An anonymous function accepting multiple arguments can be used. This syntax. Okay, so that's basically all the fancy things that you can do. But you also can do named tuples. Is a built-in data structure that is closely related to function arguments. That's not, and there's named tuples. That's interesting. Destructing assignment in multiple values. I'm not sure why that's a function, but let's play around with it. This is, unpacking is similar in Python as this, right? You just say like, in this case, if I said A is 1, B is 2, and C is 3. Yeah, so that's intuitive. And you can have return multiple values by returning a tuple. So this again is similar to Python. You do multiple return values. You can swap variables. You can do recursive destructs. Okay, argument destruction. var args functions is often convenient to be able to write a function that takes an arbitrary number of arguments. So this is similar in Python as well, where you just say, look, you can take anything. You can define it by following the last positional argument with an ellipsis. I see. Interesting. So you say bar 1, 2, bar 1, 2, 3, bar. So that's kind of cool. Let's try that. I like that. So we'll go here and we'll try this. Say bar, and 1, 2, 3, 4. Oh, I see. So it just takes the last one, the last couple, and just shoves them in. But if I have three, that's weird. Oh, I see. So it's just collecting them all in that last. I guess the X becomes like a container to hold a bunch of values. Interesting. I'd play around with that more. So we'll keep going past this optional arguments. So you can do sensible defaults again, just like Python. If I want to just paste this in here, that makes sense. The defaults. So we put some defaults here. And let's go ahead and try that out. And then if we use their example, we say date. So using dates. So if it is in fact, oh, I see. So it basically has these years, month, it has it all by default here. So if I said date, what happens? Nothing. But if I say date 2021, it doesn't like that either. What did I do wrong? Oh, I see. Why is it messing up for me? Define valid args is not defined. Function. Yeah, why is that example not working? Observe this instance calls another. The function can be called with either 1, 2, or 3 arguments, and 1 is automatically passed when only one of the arguments. So yeah, weird. I wonder why it's not working for me, but it's working here. I mean, the concept I understand, or do I do this? 8. I have to do that. It says using dates. Try it one more time. Function 8 2012 1. Undefined variable, valid args are not defined. No clue. I'm not good enough at Julia yet to know that. We'll just keep moving. And keyword arguments. So this is more intuitive to me, right? As you would build in some functions with keyword arguments are defined using semicolons in the signature. When the function is called, they're optional. Let's try that. So if we go here, okay. And then if I say plot x, plot 1, plot 1, 1, 2. Okay, so it requires the first two, but here's my code. Require the first two, but style is set, width is set, and color is set. So basically, if I was going to say print L, I could just do this. If I was going to just kind of verify this, I could say style, right? And then if I call this, there we go, right? So we can see that I don't have to set it. Okay, that makes sense. Pretty intuitive. And evaluation of scope, optional, do block. Whoa, okay, so passing functions are arguments to other functions are powerful techniques, but the syntax is not always convenient. As an example, consider map. Yeah, that's nasty. So do, for rewriting this code more clearly, map do. Interesting. I see. Function composition and piping. So functions can be combined by composing or piping them together. Yeah, so this is a good spot to go for the next time. Definitely, this is a dense section, so I can understand. And actually, I love piping, and I love functions piping. So what I'm going to do is say that we will cover this next. So episode 4, let's get into function piping, which seems really cool. There, piping. There we go. Function piping. There we go. And we'll save this. And then I'm going to get out of here. Keep this environment, say get status. Get, go up a couple. Get, CD. Status. Get add star. Get commit. Adding episode 3. There you go. Got it all set up and stop my screen sharing. So pretty neat to dive a little bit more to Julia. It's definitely, you can see the kind of academic kind of style to it. The function stuff could be interesting though. I like that concept of building a language that is really friendly to doing like function piping. F# has a lot of that stuff too. And I could see that being a reason to do certain things in Julia. So look forward to seeing everybody next week, and we'll cover function piping.